thousands of years, humans have gazed at the night sky, captivated by a tiny, fiery dot shimmering among the stars. Unlike the silver glow of the moon or the pale shimmer of Venus, this one stands out, glowing with a deep, rusty hue. Ancient astronomers called it the Red Planet, often associating it with war, blood, and fire. Today, we know this world by a name passed down from the Romans, Mars. But here's the question: why exactly is Mars red? And more importantly, what does this unusual color tell us about the planet's past, its present, and even the possibilities for its future? Stay with us, because in this video, we're going to dive deep into the science, history, and mysteries behind the red planet's distinctive appearance and what it truly means. Before we explore the science, let's rewind to humanity's earliest encounters with Mars. For ancient civilizations, the reddish glow of Mars was unmistakable. The Babylonians associated it with Nergal, their god of war and destruction. The Egyptians called it Her-Desher, literally the Red One. The Greeks linked it to Ares, and the Romans later named it Mars, their god of war. The reddish tint was seen as an omen, a symbol of battle and bloodshed. Interestingly, across cultures, from ancient India's astrology, where Mars is called Mangala, to Chinese astronomers who referred to it as the fire star, the connection between its red glow and themes of aggression, danger, and fire is nearly universal. That reddish appearance in the night sky has always been obvious to the naked eye. But what nobody in the ancient world could have imagined was that the color comes not from fire or blood, but from something much more earthly: rust. So why is Mars red? The short answer is simple: rust. The surface of Mars is covered with vast amounts of iron-rich minerals. Billions of years ago, when Mars had more water and a thicker atmosphere, this iron interacted with oxygen. Through a process very similar to how iron tools left outside on Earth eventually turn orange. The iron in Martian soil oxidized, producing iron oxides, particularly hematite and magnetite. This fine, powdery dust, rich in oxidized iron, blankets the planet, and when sunlight scatters off it, Mars appears red to our eyes. But here's the twist. If you were standing on the surface of Mars, the ground around your feet would look more of a butterscotch, brown, or golden color, rather than bright crimson. So the planet is red because it's essentially a world coated in rust. This raises another question: why is there so much iron on Mars in the first place? To answer this, we need to look at how planets form. Mars, like Earth, formed about 4.5 billion years ago from the leftovers of the Sun's creation. The early solar system was filled with dust and rock fragments. Through collisions and gravity, these materials came together to form planets. Mars ended up smaller than Earth, but it still inherited a generous supply of iron, one of the most common elements in the solar system. On Earth, much of this iron sank into the planet's core, creating a strong magnetic field. On Mars, however, something different happened. Because Mars is smaller, it cooled much faster. Its core solidified earlier, which weakened and eventually shut down its global magnetic field. Without this protection, Mars' atmosphere thinned, water evaporated, and the surface was left exposed to cosmic radiation. The leftover iron at the surface, when exposed to what little oxygen and water Mars once had, turned into rust, leaving the entire planet permanently stained. If Mars is covered in rust, how does the red dust spread so evenly across the entire planet? The answer lies in Martian dust storms. Mars is infamous for its planet-wide dust storms, some of which can last for months and engulf the entire globe. These storms lift fine dust particles high into the atmosphere, allowing them to settle everywhere. Over millions of years, this process has coated Mars with a global layer of reddish dust just a few micrometers thick. To put it into perspective, some scientists believe that if you scraped away this dusty surface, the underlying rock might actually be much darker and more volcanic, similar to basaltic rock on Earth. In other words, Mars might not have been born red, but became red because its environment turned it into a planet-sized rust bucket. Now that we know why Mars is red, let's ask the bigger question. What does this actually mean? 1. Clues about Mars' past. The presence of oxidized iron proves that Mars once had water and oxygen in its atmosphere. Without these, rusting wouldn't have occurred. This is evidence that billions of years ago, Mars was warmer, wetter, and potentially habitable. In fact, NASA's rovers have found hematite blueberries, tiny spheres of iron oxide which form in liquid water. That's a smoking gun for a watery past. The loss of atmosphere. Mars' red surface also tells the story of its lost magnetic field. Once Mars's core cooled and its magnetic shield disappeared, the atmosphere was stripped away by solar winds. This left behind a cold, dry desert world. The rust is like a fossil record of that transformation. 3 implications for life. If Mars once had enough water and oxygen to rust the entire planet, it may also have had the right conditions for microbial life. Today, the surface is too harsh, with intense radiation, freezing temperatures, and no liquid water. But beneath the surface, where radiation can't reach, scientists believe life might still exist. The color red could therefore be a clue to life's potential past, and maybe even its survival underground. 4. A warning for Earth. The story of Mars also acts as a warning. Without a protective magnetic field and a stable atmosphere, even a planet with water and iron can become barren. Mars is like a giant red caution sign in our solar system, reminding us of Earth's fragility. It's also important to clear up some common misconceptions. Many imagine Mars as a bright, blood-red desert. In reality, its colors are more muted. Tans, browns, golds, and even hints of greenish-gray. The bright red images you often see from NASA are sometimes color-enhanced for clarity. Mars doesn't glow red because it's hot. Quite the opposite. Its average temperature is about 63 degrees Celsius. It's a freezing world, not a fiery one. And despite its warlike reputation in mythology, Mars' red color isn't a symbol of battle. It's just geology and chemistry at work. So what does Mars's redness mean for us as humans looking to the future? When astronauts eventually set foot on Mars, they'll be walking across a dusty world that stains everything it touches. The fine iron oxide dust is not just a cosmetic detail, it's also a potential hazard. It can clog machinery, damage electronics, and even pose health risks if inhaled. At the same time, this rusty planet is also a treasure trove of resources. Iron is abundant, and scientists believe it could be mined for future construction on Mars. More importantly, the story of its rust tells us about its lost water. By studying where and how iron oxidized, we can pinpoint ancient riverbeds, lake basins, and underground aquifers, prime locations to search for signs of past life. And perhaps one day the same red soil that symbolizes Mars's lost past could help us build a future there, by providing raw materials for shelters, tools, and even oxygen extraction. So why is Mars red? Because it's a planet that once had water and air, but lost them. Its surface is coated in rust, spread across the globe by mighty dust storms preserved for billions of years. But what that redness really means is far deeper. It's a window into Mars's ancient past, a clue to its potential for life, and a cosmic reminder of how fragile planetary environments can be. The red planet may have started as a symbol of war in ancient times, but today, it's a symbol of exploration, discovery, and the future of humanity beyond Earth. Thank you for watching Amazing World Facts. If you enjoyed this journey into the mysteries of Mars, don't forget to like, subscribe, and hit the bell icon for more deep dives into the wonders of our universe. And remember, sometimes the smallest details, like a planet's color, can reveal the biggest secrets of the cosmos.